All right, so we're gonna get started here for our part 2 of topics in advanced Git. And we have our amazing mentor and speaker today, Raymond, is going to talk in more detail and do a follow-up lesson in presentation about his first conversation. So I'll let him give an overview of what he talked about the first time, and then really give some more direction on these advanced topics that will be going forward for this workshop. So Raymond, I'll let you take it from there.
All right, sounds good. So yeah, just to briefly mention some of the things that I went over last time, and it was kind of an eclectic mix of topics. So we ended up with this example program. It has this sort of convoluted history, like it has 2 initial commits, a bunch of merges, and so on. We looked at the internals of the repository, so you see all these objects, and there's a great deal of objects, and we'll be returning to some of these topics in this segment. I'm going to open it up though with a digression before we get back to this example program and do some more interesting things with it. I'm going to go through my Git configuration and just briefly explain each line, since this is a fairly configurable program. Some of these are good things that I think are good for people to set in general. Some of them are just personal preference. So yeah, I'll sort of go through, start with first line, or the first few lines rather, this user section. So I have name and email. It's not really a preference to set these, pretty much required to set these because you need a name and an email in order to make commits. However, it is possible to set a setting, which I don't remember the exact name of, but you can put a setting here in this section instead of a name and email. There makes Git only use repository local configuration names and emails. So if you have if you're constantly switching between names and emails, and you don't want there to be a global one that could potentially mess you up, you can set that setting here. I don't remember the exact name of it. I'm going to look in the manual page, which is the manual pages for Git they're named like for Git config, it's git-config, and this actually contains information on a very large number of settings. Trying to find user.name, but it's actually a regular expression. So the dot means any character. So maybe if I do this, there we go. Yeah, user.useConfig only. So you can set that instead of user.email and user.name. And that retrieves these names and emails only from repository local configuration. That's pretty handy. Core.editor, I just set it to VI. I just want some kind of VI like editor. I'm not like some kind of hardcore Vim user. I actually mostly don't use it. I mostly just use BSD based system VI. But I just want something that's familiar to me, and this does that. I have some aliases here. I'll get back to FF in a couple settings later, and the other ones are just they add some switches to commands. So I can do git empty if I want to make a commit that may be empty, which I find myself doing a lot of times, mostly when, you know, possibly giving a talk like this. Actually, it would have been helpful to have in part 1, but I hadn't set it yet. I set it like the other day. And then this is just a short alias for a log format that I like, although I usually use gitk. So merge.autostash, and down here there's also rebase.autostash. They're basically the same setting. So you know how you can have things in your working tree, and you do git stash, and it takes the changes in your working tree that haven't been committed or anything. It just sort of puts them away. It stashes them in a stash. And then you can do other things, and you can then pop them from the stash again when you want them back. So merge.autostash and rebase.autostash, they basically automatically do a stash before doing a merge operation or a rebase operation. And then they pop that stash back out when it's complete. They're not on by default for good reason, because the stash that you did might not cleanly apply and that would be troublesome to people. So instead, it just normally doesn't let you do merges or rebases if there's a tree, if the tree is dirty, meaning there's uncommitted, unstaged changes in it. So I have these settings on because I just want to preserve those things. Merge.branch desk is a bit esoteric. So when you do a merge, there's an option that you can pass to merge. It's --log. When you do merge --log, it adds a summary of each commit in the branch that you're merging. Now there's another thing you can set. You can do git branch --set description, which it lets you write a description for the branch overall. And then if this setting is true, then when you do merge --log, that branch description gets included in the merge message. So this is kind of esoteric. I actually don't include logs and branches that much. Junio Hamano, who I'll be talking about later, he's the maintainer of Git. He does that all the time. I don't think he includes branch descriptions, but the option is there if you want to use it. Merge.conflict style equals diff3. I did talk about this before, but when you have merge conflicts, the default style shows the left side and the right side, but doesn't show the common ancestor that the left and the right side are both changes to. This setting is, I believe it's a very important setting that people should turn on. This just displays all three sides of the merge. Okay, merge.ff equals false. So I touched upon this like very briefly, but when you do git merge, there's two things it can do. It can do a merge, meaning it creates a commit with two or more parents and joins the histories together. But it can also basically add its own option. If the thing you're trying to merge is your direct descendant rather than some other branch of work, it can instead do a fast forward, where instead of creating a merge, it just moves the branch that you're on ahead so that it contains everything in the branch you're trying to merge. And then it says it's done, and then it's true that all of the commits are now on your branch. I prefer to explicitly choose whether to create an actual merge or to do a fast forward. So the combination of two things here, merge.ff equals false, turns off fast forwarding and merges. And then I have an alias, so I can do git ff, which forces a fast forward, so that I can use either git merge or git ff to basically manually decide every time whether it's a merge or a fast forward. However, I also have this setting, poll.ff equals only. I'm pretty sure that we all use the lazy person's git pull, which is basically pretending that git pull is like CVS update or SVN update or something, and pretending that it's a command for updating your changes or updating your local copy with changes from a remote repository. So git pull is not actually a command for doing that. The point of git pull is for like Linus Torvalds to use when one of his sub-maintainers says, I've collected like all of the changes to the sound subsystem for you in this nice tag that you can then go ahead and pull. This is called a pull request. That's the original meaning of the term. It's an email to like to Linus Torvalds or someone saying, please pull these changes that I have assembled for you because I'm like your vice maintainer and I assemble changes in the same way that you assemble them upstream. So it's intended for that. Now it can be used as like the lazy man's update command, but there's a catch. If you've made any local changes, most of the time you haven't made any local changes, and so it does. So what it does is it fetches the remote side and creates all the remote tracking branches, which we saw last time. Then it tries to merge them into the current branch. Now, as I said before, merge tries to decide on its own whether to do an actual merge or whether to do a fast forward. Most of the time, you don't have any local changes, and it's a fast forward, and everything, the illusion of it being some kind of updating command is preserved. Sometimes, though, if you've made local changes, it's not a fast forward. And then since it's actually just a fetch command followed by a merge command, it dutifully goes ahead and creates a merge. And that's how you end up with these sort of content-free, annoying commits with messages like merged master into master that contain no useful information to anyone reading the history. It just sort of show up. So to allow myself to do the lazy git pull, and I have to set pull.ff to only, which means that it's basically the same as passing this merge ff only option to the merge part of git pull. So now if I do git pull and it can't fast forward, it will just abort rather than attempting to do a merge. Some people set pull.ff to rebase to try to like preserve this CVS update illusion even further. That attempt to rebase your local changes on top of the remote changes, it's not 100% accurate. But even if it were totally reliable, I still would not set it because I believe that at this point you have to stop and just manually do something that you've like decided to do on your own. Okay, push.default equals nothing. I'm pretty sure most of us here use git push a lot. That's how you take your local things and put them onto a remote. So the default for push is basically it takes the branch that you're on and just it pushes it to a branch with the same name on your remote. I set push.default to nothing because I want to be forced to manually specify every time. This is not something that the default will work for most people. This is not something that you should necessarily set. It's something that I set because sometimes I work with a lot of different remotes and a lot of different branches doing maintenance work. And when you're maintaining like a public branch, like an upstream thing that people rely on, any errors that you make are permanent. The social contract is that you can never do like a force push where you push something that isn't a direct descendant of what's already there. You can never do that to something that's like the public branch that people rely on. In your private branches that people don't rely on, or that like only your close associates rely on, you can of course do that all the time. It doesn't matter, but it's very strongly frowned upon for good reason to go ahead and do that with the public history. Like once something is in the public history, that is the history. And so to avoid any mistakes that could never be taken back, I just want to do all of my pushes very explicitly. Okay, rebase.autostash we talked about already. Rebase.abbreviate commands. If you recall, when we do these git rebase interactive rebase scripts, they have commands like pick and fix up and edit and so on. We can either give the full word for the command, or we can give one letter. And it generates the script with the full words. So this setting, abbreviate commands, makes it instead generate scripts with one letter. And the reason for that is it's very simple, really. I use VI or VI-like editors. And when you do that, it's very simple to change one letter with just R. You know, F abbreviate commands, that was just 2 keystrokes there. That was 2 keystrokes to change it back, whereas changing, like removing a whole word and changing it is like 4 keystrokes or something. So that's just a time saver based on the editor I use. Okay, re-re-re.enabled equals true. We talked about re-re-re before. It saves merge conflict resolutions and replays them when you hit the same merge conflict again. I'll be talking more about that. Okay, send email.annotate equals true. I'll be talking about sending via email. But basically setting annotate equals true gives you the opportunity to look at and edit each email that you're about to send before you send it. So it's nice. And then I have email server settings, which obviously you'll set those to your email server if you set this up. Status.show untracked files. I'm sure that you've probably like added new directories to Git repositories before. You may have noticed that Git status, before you actually add the directory, it just sort of shows the directory rather, whereas normally Git shows you all of the files that have changed. So this just makes it show every file in the directory if there's an untracked directory. It's just a personal preference. And then filter LFS, this is just from installing Git large file storage. It's not really important. It automatically adds this section. All right, I don't want to save my changes. Okay, So that's my Git configuration file. Some of it's personal preference, some of it you might want to adopt. Now we can get back to our example program. If you recall, we have these various files. And compile it. It does, it prints hello. It's a very featureful program. It has a version option. Right now, we haven't released anything, so we're not really on a version. So I would like to release this. So let's look at the log again. Okay, so we have this sort of ASCII graph that we get from doing, if you recall, this is an alias for one-line graph, meaning each commit goes on one line and then it displays a graph. So we have these commits. If you'll draw your attention to, I changed my mouse highlighting thing to work better on a dark background, and now it turns the rest of the screen lighter. So if you'll draw your attention here, if you recall when we talked about merge commits, they have 2 or more parents, and as you saw when I crashed my laptop, loading a big one from the Linux kernel or more can get pretty high. The order of these parents doesn't matter, except that the first parent does matter. And there's even a special option to only follow first parents. So like the first parent history of your project's main integration branch is a special one. This is kind of the log of everything that you as the maintainer have done to integrate the project. Usually this is a bunch of merges. Like you wouldn't want to make substantive code changes here. Rather, it's kind of like a way, I don't know if you've used editors where you can sort of fold sections of code away to not look at them and then you can go deeper into them, or like any sort of directory tree browser that does this. It's like that in a sense for the commit log. You can get an overview of the history from looking at the first parent history, and then you can dive deeper into specific things that you're interested about by following other parents of a merge in the full log. And again, another upgrade from the previous iteration, I've increased the font size on Git K so that it's hopefully a bit easier to see. And again, this is easier with a graphical tool like this usually. You don't necessarily have to use Git K, but it's the one that comes with Git, so it's very well supported. Like here, I can follow the first parent history. It's very simple. But say that I care about the branch make clean. Okay, so I know that it's the second because it lists them in order in the merge message for this octopus merge. So like the first parent is the first parent, and then second, third, fourth, respectively, are make clean versions and make install. So I can then go and follow it. I can click on these links here, and now I'm following this. I can go backwards in time or forwards in time with parent and child links. And here I am back at initial commit. So that's pretty simple. Yeah, now I can make a release. And I said that a lot of merges go in the first parent history, but sometimes other things go in the first parent history. For example, releases. It's pretty common to update some kind of version metadata when you do a release. In this case, I'm changing this the version header file to 0.1. There we go. Look at this again, version 0.1. This is not a merge commit, it's just a regular commit, but it's still a maintainer action because maintainers are the people who cut releases from the source tree and decide what goes in it and so on. So we've done that, we're at version 0.1, but we haven't quite released it yet. There's another thing that you have to do. You have to tag it. And yes, I am writing a message here, but it's not a commit, it's a tag. This is the fourth type of Git object. So we talked about previously the 3 most important types of Git objects. Those are blobs, trees, and commits. The fourth type of Git object is a tag. Now you notice that I did git tag -a rather than just git tag. If you just do git tag, it creates a lightweight tag, which isn't really an object. It's more of a ref. It's basically just taking a commit hash like CF0, AFB7, etc., and giving it sort of a friendlier name. These lightweight tags are also what you use when you're making a pull request in the original Linux kernel meaning of the term to Linus Torvalds. You create like some tag changes for Linus, and you say, please pull from this tag, and then he goes and does it, and it's all very nice. But an annotated tag is an actual object. So let's look at it. I think, is it? Yeah, rev parse. And there's of course, an eternal bike shed debate over whether you should put a V in front of your version tags or not. The answer is it doesn't really matter, but Junio does it, and what Junio does is always correct, basically. Like if you do what he does, you're never wrong. And so that's why I've done it here. I've just included a V. Some people don't include a V, so the tag would just be 0.1. And it's fine. It's not something to get worked up about, really. Okay, so this is the SHA-1. Let's if you remember, I have this little shell script git cat to display the contents of Git objects. So objects.
As you're doing that too, Raymond, one
Yep.
question came in is, what's the difference between lightweight tags and branches?
The difference between lightweight tags and branches. A lightweight tag just sits in one place and identifies one particular commit hash forever or until you delete it or like manually change it. A branch is something that you can actually check out and that moves with you when you do commits. There's a lot of like tape deck metaphors in Git, I find. And one of them is head for like the recording head. And like branches are actually called heads inside the repository, like they're refs/heads/ whatever. And they're called heads because they move like I mean, does the recording head and the tape deck move? It does in like a phonograph record player, but anyway, their metaphors are like all software metaphors, a bit mixed. But that's the main difference. A tag just sits there naming something. In a branch, you can actually check it out and commit to it, and it will move ahead as you commit and so on.
Great. Another one was the difference between setting up aliases in the git config file in, say, -rc or .profile.
Well, I mean, you can't really like. I mean, I guess you technically can. So you're actually adding something to the git command itself. Like if I do git l, that's a subcommand of git that I'm creating. Like the first thing it does is check for built-ins. Actually, I think it checks for aliases first because I think you can alias a built-in command to something else. I don't remember though. It either checks for aliases first or built-ins first, then it checks for the other one. Then it starts searching your path for binaries with special names, like if I made something git l. I don't think you can actually use a shell alias, though, because Git has no idea where it would search for a shell alias. They only exist in your shell. Like if you made a script that was an actual file called like git-l, you could create something that way. I don't think a shell alias could allow you to extend the git command itself. But you could like create a shell alias gl that expands to git-l or git-log, whatever, or so on. You could do that. So I've used this our old friend gitcat that I used extensively in part 1 to look at the tag object. You can see it's like other Git objects. It says it's a tag. It says what it is in the beginning. Got this header, then a 0 byte, and then its actual contents, object, and then a hash. So CF0, AFB7, etc. You can see that's what it points to. What does it point to? A commit. And then the tag name, the tagger, the timestamp, and the tag message. Tags have their own messages. They're not the same as the underlying commit messages. They are they're their own messages. Let's see. So that's the fourth type of Git object, the tag. If you're familiar with the releases tab on something like GitHub, all of those come from Git tags. You basically like creating the tag in the public repository is basically the release process for pieces of software that use Git. Once the tag is rolled up, it can also be signed with GPG, but like 90s cryptography like GPG leaves a lot to be desired. You know, you can set it up in your Git configuration to automatically sign with a key, and you know, it's fine as far as it goes. Some people do it on every commit, which is a bit excessive. Doing it on like your official blessed release commits with like your known release signing key is a happy medium. A lot of people do that. Let's see. Then, you know, you have to roll up your archives, like your tar.gz files and your zip files and so on, containing the source for that release, which something like GitHub does for you automatically when you have a tag. Yeah, there's also a Git Archive command you can use. Let's see. To create like a tar.gz. I'll give it that name. And I'll do it from the v0.1 tag. Here we go. You can see I just listed inside the archive. It contains our version 0.1. So that's basically all. So what else can you do with proper version tags? Another cool thing you can do is Git Describe. Now, this isn't very exciting. I just did Git Describe and it outputted v0.1, which is, you know, the tag that we're on. So like, it's not exciting yet, but it will be once I make some more commits. So I'm going to start making more commits. Let's see. Okay, I'm only going to use this version, define this version constant if version isn't already defined. Let's see. Okay. Having made a commit, this is now substantially more interesting. Now it starts with v0.1, but then it has other stuff after it. So let's see. What this basically means is v0.1, we're one commit after it, and here's our hash. It basically like uniquely identifies positions like after a tag. If I did it before the tag, Git Describe wouldn't. It would look backwards and try to find a tag, not find anything, and then it would complain. But using since I have Git Describe, since I have a tag rather, I'm able to use Git Describe and get sort of a unique version number string for each individual commit that I could potentially check out. Okay. So the reason that I did that was, and I'm going to be copying this from my notes because it's really annoying. So that I can include it in my builds. This I am not even attempting to figure this out on the fly because it was really annoying to figure it out because makefile syntax is not the friendliest. But basically, what I'm trying to do is if Git Describe actually returns something rather than just erroring out or not existing, then I want to when I do the compilation, I want to define on the command line version to be whatever Git Describe returned. Okay, and then let's see. I believe that works. Let's see, I guess make some kind of error. Let's see. I probably made some kind of typo here, or rather some typo when I was transcribing it to my notes, and now yeah, comma dversion equals. Oh, yes, here's the typo. There we go. Now all the syntax highlighting is nice as well. Okay, and as you can see, the compiler or the compile command now has the version from Git Describe. And if there is no Git Describe, like if I just downloaded a release rather than checking out a Git repository, so there's nothing for it to Git Describe, then it will just use whatever I have in that original version.h file. That. There we go. So now, no matter now, the version output will always give a unique build number for everything. However, this make file is no longer like a standard POSIX make file. It's now a GNU specific make file. Yeah, I'm just going to rename it to that. Okay. Let's see. Okay. I'm going, I have, let me look at the history just to show it. Okay, so I have master version 0.1. I have this build numbers branch. I'm going to merge it. And then I'm going to make another release. Actually, you know what? I'm going to show off that merge -- log option that I was talking about when I was going through my config. It just adds these nice little descriptions of the branch or branches that you are merging with the short logs from the commits. That's nice. Okay. I've done that. Let's see. Now my versioning procedure here is just editing version.h. Committing it, tagging it, and here's where I would put a nice change log describing what's in this version in the tag message. Okay, now everything from this version onward will have the ability to show the build number from which it was built in its version string. So that's pretty handy. You know, it can be a bit trickier in when you don't have a compiled language that you can bake, where you can bake constants into the binary. But it's still a very useful thing to have around. All right, so I've actually I was going to make a release. I ended up making 2 releases, but neither of them are published. I'm going to go ahead. I'm going to publish them. I'm going to have this here. I'm going to create and name this repository. Okay. Copy this. Okay, now I've added first I've gone to GitHub, created a repository. I've added it as a remote here, so it's accessible from my my on disk repository. Let's see. Go ahead and push the branch. And push the tags. There we go. I'll refresh this. And you can see it here. And you can see it already has releases, which were created from the tags. And they do display the messages. And you can download archives right from there, which the site has already generated, or maybe not generated. Maybe it generates them the first time someone clicks those. I don't know. So that's that. And I have these branches. I actually have these remote branches. Now docs is, if you remember from the end of the previous session, I basically took some documentation and sort of merged it, despite it being a completely different history. So that's the remote from that. GH is the one I just added. Now there's remote tracking branches tracking it. Okay. Refs, those are stored in the Git repository under like refs remotes, GH. I've got that. They're special because they're in that remotes directory, but they're just the same refs that you have anywhere else. But they only update when you run like fetch commands, which I can do now, but it's not going to give me anything because there's no changes. Okay, let's see. Now this, I'm going to go ahead and this is going to be really confusing because I'm like forking it to myself and so on. This is probably what many of you do in this case. So I'm not going to clone it. I'm just going to add it as another remote, which is, I think they usually put a URL. I mean, I can just copy the same. So I'm going to pretend to contribute to my own project from another account. It's going to be a confusing mess probably, so just bear with me. Okay, so what do I want? I want I'm going to add a license file to this. You can consider it ISC licensed, but I'm only actually going to add the file now. So let's see. Just add a year. Okay. Now I'll push it to my remote, and not the upstream one, but the downstream one. Okay, nice. Let me refresh this. I typoed this. I did nothing by pushing master. I wanted to do this. Push add license. Okay, cool. And I can do this, add license to the upstream repository. Okay. Now let me pretend I didn't just do this myself, and that I'm the maintainer again. So maintainers sit on integration branches. Okay, so now as the maintainer, what I would do when I see this pull request come in, I'm not going to press enter here because I've already done this, or actually I think I can still press enter. But what I would do is I would add this. It wouldn't be the SSH version. It would just be the HTTP version because I would be adding it read only. And after doing that, okay, now I can review what they've sent me. This is kind of a typical way that I would do it. I would just look at the history, look at the diffs, and so on. In this case, I don't really have anything to add. It's good by me. So I can merge my contributor's contribution. You'll notice that I merged the remote tracking branch, and the automatically generated merge message makes note of it. Okay, that's done. Now as the maintainer, I can officially publish this. And all this remote juggling, you can see why I set the push default to have to be explicit. Of course, I can still typo it if I'm not paying enough attention. Okay, great. So this is closed automatically because I merged it. There we go. We have a nice ISC license there. Okay, that was kind of nice. Of course, I'm an old school Git user, so I also accept patches via email. And I'm going to email a patch to myself now. So let me, I'm another contributor version of myself. I'm coming along to this repository, and I think, I should probably mention that I accept patches via email in the README. So here I am in this branch, the README. Okay. Okay, cool. Now I have this nice branch. Now, how do I email it to someone? Well, Git helpfully provides a command, send email. You saw in my configuration that I have it set up. The syntax for it is, it's the same as like Git rebase syntax, where you provide it like what the name of whatever is upstream to you, and it collects everything that isn't in the upstream. So in this case, send email master. If you're not familiar with these sort of rebase-like syntaxes, it might look like you're sending an email of master, but you're not. You're sending email everything on the current branch that is not on master. So annotate. Okay. So this is like the most confusing part. The subject line is the first line of the commit message. Everything in the email body after it, but before these 3 lines, is also part of the commit message. I'm not actually going to add anything there. Everything after the 3 lines. Okay, everything after the 3 lines, but before it says diff -- git, etc. Including this automatically inserted like diff stat. Those are just, they're ignored by all the software. You can put your freeform message that doesn't go in the commit log here. And then the actual diff is below. Okay, that's good. To whom should the emails be sent? Send them to myself. I'm not replying to anything. Okay. Now the CC list above has been expanded. Basically, it automatically CCs you. So you're not sending this from like a mail client that has the ability to copy it to a sent messages folder. So in order for you to have a copy of it, it also CCs you on it. And additionally, if there are email addresses mentioned in the commit message anywhere, it'll add those to CC automatically as well. Okay, I'll go ahead and send this email. Wait for that for a second.
One question that came in is, can you also use git request pull command?
Git request pull. Yeah, so I'm not actually going to use it here, but I'll bring up the man parade briefly. So there's a nice git request pull command. And basically it literally just generates a nice description, sort of like the merge log that I showed with merge -- log. And it basically puts together an email to Linus Torvald saying, please pull this. And that's exactly what it has in the example. And that's all it does. It's like takes your local tag, or rather takes your tag and asks someone, please pull from this tag. meaning please merge the history behind this tag, basically. So it's not something that I really use, unlike send email, which I use all the time. Okay, so I sent an email. That's good. Now I'm going to change personalities here. I'm a maintainer again. Okay. I'm reading my email using this email client. I notice, hey, a patch came in. Okay, it's very nice. I think this is a good patch. I agree with this patch. If I didn't, I could reply to it. You know, I could apply to things inline. You know, that's a stupid comment, but that's just how you'd comment on something. Okay, so let's say I just like this patch. That's good. So as the maintainer now, I'm going to use a style that I copied from Junio, which is you take the contributor's initials and then a slash. So I'm going to put my initials there. Okay, now I'm on this branch. I'm going to open my email client back up again. Have a lot of emails in here from various mailing lists anyway. I'm going to pipe the whole message into git am. Am it's actually git am, it's short for apply mail. And if you look at that, it's been applied. Let me look at the longer git log actually. So as you can see, it just git am just read the message from standard input. That's why I piped it from my mail client. It took in the message, converted it to a commit, and it applied that commit. Now, so the author is from the email. The committer is me just now running git am. And then, you know, it has the body of the email and so on. And then the actual patch is applied. So that's all. Yeah, I'm in the right directory. Here we go. Okay, I've updated the README. And I can push that change. So that's how it works with email. The two ends of it are send email, which converts commits into emails, and am, which converts emails back into commits. If there's more than one commit in your branch and you're sending multiple ones, it ends up sending a bunch. Let me show you an example. Go to mark.info, which is mailing list archives for a lot of projects. I'll go to the Git list where there's a ton of these. You see they have these names like, you know, patch 0, patch 1, patch 2. So when it's patch 0, it's actually a cover letter. And I want to go earlier in the thread to the actual patch 0. It allows, if you have a whole series of patches, it allows you to send a cover letter. And then the cover letter talks about like the whole branch. This should look familiar. It's like it's basically the same as the git merge -- log output that would be generated if you merged it. And then let's see. I think and then the actual patches are as you see before. I think I didn't really want to use public inbox for this because the fonts are really tiny, but it's actually a better way to browse this mailing list because you can see all of the patches together. So I'll just look at something else. They look like this. You see the subject line and then this stuff go into the actual commit message, click down to the signed off by. This is just a note in the email, just to clean up that we were taking, etc. Down here is the actual patch. And so the great thing about this is you can take any of these commits, you can reply to them in line for the actual commit itself. This is pretty important, and it's what allows you know, such a rigorous standard to be applied to each individual commit that goes into Git by Junio. Like, this is just a tiny change, but here's several paragraphs from Junio talking about it. This would be pretty difficult to do if they were all squashed together into a single thing. So there's a lot of advantages to working with mailing lists. Let's see. All right. So I'm going to sort of jump to a different topic. I'm going to go to a more internals topic. Okay, you recall we look at the tree. We have a large number of objects here. Some of you may have wondered, or it may have crossed your mind, does it get inefficient, especially considering, remember, each blob object is the full file at that revision. So like if we have a large file and we're constantly changing one line in it, we're actually storing a different blob every time of the whole file. Does this seem inefficient? Yeah, maybe. It might be inefficient. And also notice RR cache down here. This is git re. This is where it stores merge conflict resolutions. Okay, so now normally Git garbage collects stuff itself. I'm going to manually garbage collect it by running git gc. Okay. Yeah, now our list of objects has gotten smaller. Actually, it packed every single object. So there's no loose objects anymore. There's just this mysterious pack. What could it mean? Well, so for both network usage and disk space usage, Git will take loose objects, loose objects meaning they're in their individual files like we've seen thus far, and pack them into pack files. You see two files there. The first one ends in .idx. That's an index that lets Git easily find the location of files inside the pack. The pack is the actual data. And it's delta compressed, meaning that for files that change a lot, it takes one revision of it, stores that as the revision, then stores other revisions as changes to it. So that gets rid of your problem with having a large file with many changes. And it's also, I think, just compressed regularly, which is an advantage over compressing each one individually. Like if you have one file and you're compressing it, you can only take advantage of redundancy in that file to make it smaller. If you have a bunch of objects, you can take advantage of redundancy across the whole class of objects in your pack to make the whole pack smaller. So the compression is actually improved as well. Okay, now. I'm going to remove the index. The index is not strictly necessary. Git uses it to read into the pack and find the individual objects, but all the data is in the pack. I'm going to take the pack out of there. Okay, so now we're sort of in big trouble. We have no objects because I just packed them all into a file and then yanked them out of the repository, so we don't have any objects anymore. But I did that for a reason, so that I could demonstrate Unpack Objects, which takes a pack and unpacks it into loose objects. And if we look at that, all of our loose objects are now back. Unpacking it's not something you would normally do. Git runs quite well, in fact, nicer in some ways when things are packed. It's just sort of a trade-off that it makes. I don't need that because I unpacked it. Okay, so that's pack files and how Git stores objects. There's a lot of performance stuff like this behind the scenes. It's very easy to create something that Git will accept as a valid repository. It's not always so easy to read what Git created in your own code because it has so many complications and tricks that it does for efficiency. It's usually best to use libgit to read the repository. Something related to this, if you remember back in part 1, I was doing Git clones from directory to directory on my disk. I'm going to do that again. Okay. I just wanted to talk about a way that normal file systems might be more like Git than you might expect. So there's actually, I could have just copied example to example clone. Now that wouldn't have set up like the remote origin inside the clone, but it actually would have had other effects than that. Doing a clone like this from directory to directory doesn't actually do a copy. It does hard links. So let me show an example. So like the working tree files are still individual files, but the object database is actually not copied. Instead, hard links are made to it inside the clone. If you're not familiar with hard links, you might be familiar with symbolic links. Symbolic links are like, they're sort of a fake file that you put somewhere that says, hey, the real file is actually at this path. Hard links are different, and technically all files are hard links. Let me look at an object with the I option. .git objects 01. Yeah, this one will do. Okay. So there's two things I want you to direct your attention to. The first is this number. I got it by passing I. This is the inode number. So entries in a file system, like in a normal file system, at least on Unixes anyway, the actual file data is just stored somewhere on the disk by number, which has nothing to do with the directory paths and so on. And then the directories themselves contain entries. In this case, it says it's like this directory 01 has an entry that says FE1288, et cetera, points to inode 864.835.9102. Okay, that's fine. But what should, if not obvious, then at least not non-obvious, what should be not non-obvious, is that if you can do that, then what stops you from taking two different paths in your file system and pointing them both at the same inode number? The answer is, of course, nothing stops you. This number 2 here, most of the time in this ls output, we ignore that number. That's the number of hard links, meaning the number of directory entries pointing to this inode. So as you can see, normal file system stuff is somewhat similar to tree and blob objects in Git in one way. In some ways, there's one crucial difference. You can edit a file in the normal file system. You cannot edit a blob object in Git because it's stored by the hash of its contents. You can only create new blob objects that are similar. So yeah, I'm just going to look at inside my clone. What does that object look like? Well, you can see the inode number is exactly the same. And by the way, every file, at least in Unix file systems, is a hard link. So like if I delete these, what happens is this number goes down by 1. And when a file's number of links number reaches 0, that's when it's deleted and the file system can go ahead and garbage collect the space used for it. So it's just basic reference counting. But they're both equally the same file. Like neither is a symbolic link to the other. It's not like a shallow copy either. If you edit one, you're editing the actual underlying file. So in both places it will be edited because they're both the same file. Whereas if it were a shallow copy, they would only be the same until you edited one. It's just they are literally the same file. And that's the reason I bring that up in a Git talk is because Git was explicitly designed to be a file system first. Linus Torvald described himself as someone who like a file systems guy or something along those lines. He said, I understand file systems, so I designed Git to be a file system. Indeed, that's basically how file systems work. The difference with Git is that instead of just some arbitrary inode number, it's actually a hash of the contents. So let's see. On a similar topic, since we're discussing like space-saving features, I'll go back into this repository. Okay, I'll discuss what I think of as a fairly new feature, but actually it's been around for like 5 years now. Work trees. So you remember I discussed before, like the .git directory and all the stuff in it is, that's our object database and our refs database. That's like our backend database. That's the actual Git repository. And then, all of these nice files that we see and we edit in our day-to-day use of Git and that we commit and so on. Those are basically just like a friendly front-end interface to the actual nuts and bolts of the back-end database. So, the question is, what's to stop us from attaching multiple front-end interfaces to this? And cloning is not really this, because cloning makes another database, even if the underlying database might be the same files in the file system. You're still, in the end, making another Git repository. Okay, so work trees are, there's always, at least if your repository isn't bare, like if it's a normal repository, there's always one main work tree, which is the main directory. So that's it, it's the one we're in. You've actually been in a work tree all this time, or at least since 2015 or so. So here's all the commands for Git work tree. They're pretty simple. So what you do is, let's say that I want to keep this particular copy of the repository on the master branch for whatever reason, but I want to simultaneously work on some other branches. Maybe I'm doing like integration work, but I also want to do some coding. I don't want separate copies of the repository. I just want to be able to flip back and forth. So work trees are great for this. I'm going to do in the parent directory. I don't want to create a work tree inside a work tree because that would be kind of confusing in various ways. Okay. All right, I did this before. And yeah, I did this before and forgot to remove what was left over. Okay, there we go. Now you can see preparing work tree, checking out topic. So doing this is kind of like checking out a branch, but it's checking it out into a totally different directory. So I have this. Okay, cool. You see files are there. It's very nice. Let me just list everything. Okay, cool. You see .git in there. What's inside .git? Well, and I may have spoiled this by doing the big list. It's not a directory, it's a file. So inside a work tree that isn't your primary work tree, .git is actually just something that it points to the real Git repository. And you see it actually points to a directory inside it, work trees topic. Now you remember how I said that every repository has a head, which basically describes what's currently checked out. Well, a work tree needs a head as well, and it needs some other stuff. That all lives in there inside the work trees directory. Now, you can't point two work trees to the same branch. If you think about it, this is a pretty reasonable safeguard because you could get into basically unresolvable contradictions if you tried to actually commit things from both of them. So it's basically just a different way to check out a branch. Instead of checking it out into your work tree, you check it out into a totally different directory. And you can remove them with git work tree remove. You can also just delete the directory, and Git will eventually garbage collect its work tree references. So I think that is pretty handy. Okay. Now, the next topic I want to talk about, first I'm going to have a drink. Okay, the next topic is actually merging. So I did mention this in part one. I'm going to mention it again. I mentioned it earlier today, actually. Merging is a fundamentally three-way operation. What does that mean? What that means is, here we go. Okay, so if I have, actually, I think I prepared a specific example for this. No, that was a different thing. Sorry, forget that. So basically, if I have a commit and I have a commit, like let's pretend these aren't merged together and these are just commits because I forgot to prepare something for this. let's say that I have, two commits branched off of the same thing. Then to do the three-way merge, this is kind of the reason there's a commit graph at all, really. Well, besides it being a nice way to represent histories. It's so that you can walk the graph backwards from both sides of them and find the most recent common ancestor of both commits. That's how you take your three-way merge algorithm. That's how your three-way merge algorithm knows what the old version is that it has to compare the left and right versions against. So there's actually a command for finding merge bases. It's called git merge base. So let me, there we go. So let's look at this this piece of log here. Git merge base. Let me do something simple. Let me do the merge base of this commit and this commit. Obviously it's kind of weird and doesn't make sense to merge them, but what's the merge base? Like, what's their most recent common ancestor? And the answer is it's this commit itself. Because you go backwards from this and you find this. For this, you just stay on it. So a lot of operations in Git involve finding merge bases. Like obviously merges do, but it comes up surprisingly often. So there's an experimental feature that it's not yet ready for prime time. I think it's actually so experimental you don't even get it if you turn on experimental features. Commit graph. So the thing about the commit graph is, as we've seen, to actually walk the commit graph in Git, you kind of have to open up a ton of commit objects. And repositories over time grow a lot of commit objects. And there can be a lot of parents to follow and so on. Walking this graph can get to be fairly time consuming. And so the experimental work in commit graph is to create commit graph files. So this is going to improve performance for like logs and merges quite a bit when it comes in. Basically, it only works on things that have been packed, like loose object, it still just reads the objects. But it basically reads all of the pack files in the repository and outputs its own file that contains just the commit graph structure. Then when you want to do a log or when you want to do a merge base or find a merge base, you can look at the commit graph. And like it's very experimental, so I don't have a huge amount to say about it. Just that it's going to improve performance a lot. Let's see. All right, I think the next thing I want to talk about is, how did we arrive at Git itself? Like, how did this happen? So version control systems have sort of a long and storied history. The most basic thing you have are these basic Unix programs, patch and diff. Patch and diff, they do basically what you would expect. If I have two files, there we go, and that's actually the, we're probably more used to seeing unified diff, which everyone agrees is a better format. You need diff-u. Okay, so the very earliest things are diff and patch, and actually diff3 exists. It does three-way merges like I've been talking about. So if I have, let's see. I have this nice example file that I use all the time. I make changes to it on the left and the right. And I can do the merge. If I have a conflict, then that's it displays the familiar conflict markers. This is where they come from. They come from very old Unix programs. Okay, cool. So that's like the very oldest and simplest thing that you can do is you can store patches, but this doesn't actually track version. It's just like a way to describe a change to a file. And the patch command, by the way, just takes the output from diff and applies it to a file. It's like the inverse operation. Okay, so a very early version control system is called RCS. RCS works at the single file level. It's very simple. Okay, and I have this file. I use CI, which is short for check-in. Okay, cool. You'll notice that it's disappeared. The sort of behaviors that we're used to are not actually standard now. When I said check in, it assumed that I wanted to, actually check it in somewhere, which it's not what we're used to. So let me check it back out. There we go. Let me listen again. You'll see it's actually, when I checked it out, it's actually read-only. That's because I didn't check it out for editing. Let me check it out for editing. Just CO. I don't use this very much, or actually, I literally never use this program. It's an ancient program of historical interest. So I'm reading my notes. -L. Okay, now it's writable. Okay, I can make a change to it. Use the -U option to prevent the file from actually disappearing. Here's where I enter my commit message, such as it is. Okay. Now I can look at the RCS log. There we go. I can look at the diff. There we go. So this is like the great ancestor and great grandfather and so on of all the version control systems that we use now is RCS on ancient Unix. Does it have a history section in the man page that says just how old it is? 1985. 1982. I don't see a history section though. It's a shame. It's at least 1982 old. It's probably from the 70s though. Okay, so that's like the most basic thing. So the next big advantage, or the next big advance rather, in version control systems was CVS, which I'm not going to demonstrate because it would require me to set up a CVS server, which I didn't. That would have been a real headache to do for very little benefit. I'll just tell you, CVS is RCS, but it's RCS over the network with a server. When I say it's RCS, I don't just mean that it's like RCS. I mean it's literally a bunch of scripts wrapped around RCS that enable you to check out something from a server over the network, check it back in over the network, and so on. And this was basically the standard in version control for a very long time. There are still projects that use CVS. Like my favorite operating system, OpenBSD, is still happily working on CVS because it's worked for them for a very long time, and they don't see a need to change it. When I contribute to OpenBSD, I actually usually use a Git mirror, and I just use Git send email. And that's a great thing about emailing patches and so on is, like, it's not that Git invented emailing patches. It's rather emailing patches was around from the very beginning, at least as long as there's been email in the patch program. And Git just built these tools around it. Like the Linux kernel was emailing patches around before Linus Torvalds wrote Git, and it was developed to support that workflow. But it's a standard workflow. People using CVS can still take my patch and apply it in CVS commit it if they like it. A downside to CVS is that people weren't actually able to view the development in progress because you needed a CVS account. You need to be a developer with a CVS account. The OpenBSD project, again, tried to solve this. They have anonymous CVS where you can do read-only CVS operations as anyone. It's done over SSH, and it was like a very early sort of way of making your version history public, which has actually not been the standard until relatively recently. So there was Subversion for a while. I think Subversion natively supported read-only checkouts, so people could review these. Subversion basically tried to copy CVS in its user experience. The difference with Subversion was that now you saw that RCS is based by file. CVS, being just a bunch of scripts on top of RCS, is also by file. Subversion versioned the entire repository with just the sequence number that went up every time. This is a big benefit in a lot of ways when you can actually have a version number that applies to the whole code base. Whereas previously, that would be something someone manually rolled out of the CVS tree. CVS had tagging. It was sort of like what we think of as version tagging now. So after that, basically, Subversion tried to get people on CVS to switch to Subversion. They were successful in some ways. Git was kind of, it wasn't really out of left field. Like the time of distributed version control systems where just everyone has an individual copy of the repository and can do all version control operations themselves. The time had basically come, and Git just happened to be sort of, partially it's very extremely powerful and performant. Partly it's that the Linux kernel has a sort of cache that made it attractive. But yeah, it reached a lot of adoption relatively quickly. It's kind of the de facto standard now, which I'm happy with. It's not perfect, but it's actually, I think, can be rated a good system, which not too many things can be rated a good system, but I think Git, the software, can. As far as why GitHub is popular, so a lot of people, open source projects used a site called SourceForge for hosting, which was progressively getting worse and worse, filled with more like ad banners and malware. And they sort of appeared with this trendy new tool, basically at the right moment in time. So even though they don't actually implement Git correctly, and it would be nice if they took some of their money and fixed some very basic things that could be done, probably overnight by many people already working there, it still was a pretty huge benefit to open source that it came around, despite the problems with centralization. People badly needed to be rescued from SourceForge. I think at one point, I was not actually exaggerating when I said malware. I think at one point they were actually serving malware as packages. Things did get pretty bad. But of course, Git is not actually the end of history as far as version control. Did I create something? No, I guess I didn't. I just want to show off sort of, I don't consider it like production ready or anything, but it's a version control system called pjoule with the property that there is not actually such a thing as a merge conflict in the sense of the Git. Three-way merges can still conflict, but it's just that this is a perfectly valid state for the repository to be in, rather than something that that makes you stop and resolve it before you can use your repository again. Okay, so this is definitely not a version control system that I use very often. But basically, once upon a time, there was a version control system called Darks. It was distributed. It went very far. Like I've talked before about how you can view a commit as a commit and also as a patch. It went very far onto the patch side of this and only had patches. pjoule is sort of a spiritual descendant of this, but without the terrible exponential time algorithms that doom Darks to obscurity and lack of use, even in the sort of insular Haskell community. And yeah, it has the nice property that I'm about to demonstrate. So I'll make a file. I really need some kind of script to generate this exact file because I make it a lot. Let's see. I don't know the commands for this. I found them, I figured them out and wrote them down in my notes. This is basically making a commit. Typo. Okay. Now let's see. this pjoule fort command is basically checking out a branch. Let's see. To alternate. Okay. Meanwhile, you know, on some other branch, I do some unrelated work. One thing I do like is that it automatically does the sort of git add -p thing where it asks you about specific changes. Okay. Okay, that's good. I'm basically doing the equivalent of merging the alternate branch. Oh no, a conflict. And indeed, there is a conflict. But so far, this has all been just like a weird alien, weird command version of stuff that we could do in Git. But this is something that you absolutely cannot do in Git, which is this. I just, despite there being a conflict, the repository was still just in its normal state. It actually just, it's able to accept, rather than version controlling on files, it actually version controls on files which may have conflicts in them, more or less. There's an interesting paper about this that I can provide the link to. Basically, files in pjoule are allowed to have alternatives for each line, more or less. And this is just a perfectly normal state for it to be in. So I was still able to merge my other branch despite there being an unresolved conflict. And if I do resolve the conflict, all I'll be doing essentially is just committing another patch that takes it from, you know, multiple alternatives to one alternative. And yeah, I forgot to demonstrate, but if it did in fact just get merged perfectly cleanly despite there being a pending conflict. Yep, I think that's about all the topics that I can cover.
Yeah, we did have, I'd say one question that was submitted ahead of time, and maybe you've touched a little bit on it, but we can revisit. Do you see any other version control systems taking over in the future? And then again, you mentioned one of the features, but any additional cool features you can think of that Git doesn't have?
Yeah, I mean, this is the main one. I think that the version control system of the future, I don't think it'll necessarily be like as patch heavy as pjoule or as Darks was. I think it will, at least at the very least, have the ability to not stop the world and demand a resolution whenever there's a merge conflict. I'm not sure, like there's a lot of theory into representing repositories solely as a collection of patches. I do like this in some ways. Like my ideal branch history is, you know, you make a version, then there's branches from that version, and then at the end of all their development, you octopus merge them together once, and then you release the next version. That's like my ideal Git history. Obviously, reality intrudes, and it's not usually like that. But the reason that I dream of such wonderful octopus merges is fundamentally, so like the ordering of changes, it's sometimes fake. Like it sometimes literally doesn't matter whether you did one thing first and then the other, and the commit graph is just sort of giving you like it's what's the opposite of information? It's like anti-information. It's saying, you know, here's the commit graph that tells you this came before this, which is just irrelevant, useless information that happened purely by chance. It could have been committed in the other order. But on the other hand, in actual software development, a lot of times the order does matter, either because something depends on an earlier patch, or more commonly, because they conceptually depend on one another. Like the the conceptual way this change works is, first you do this, then you do this, then you do this. And like you're recording not the real development process, which probably had a lot of false starts in it, but like the idealized development process that you want future readers to look at. I think ultimately version control systems of the future are going to need to reconcile these tensions somehow. I'm not sure exactly how they'd be resolved. If I were sure, I'd probably be maintaining a version control system myself. But I think that these sorts of things matter. I think the human factor matters, and by that I don't mean the usual complaint that the Git user interface is bad. I don't actually think it's bad. I think it makes perfect sense for the most part. Some of its defaults I don't agree with, but it makes perfect sense. It's just that people have developed this cargo cult of explaining it wrong not on purpose, but just because someone else explained it wrong to them. I think that that's something that the version control system of the future will have to come out from the gate swinging in trumpeting its the correct mental models for viewing it, which Git didn't, because you were just even though at the beginning nobody except Junio, Hamano, and Linus Torvalds understood it, they just sort of put it out there and told you you can go and use this. So the version control system of the future will probably need to explicitly force people to accept whatever mental model it comes with out of the gate, so they don't come up with superstitions. I guess that's my sort of rambling answer to that question.
Perfect. Well, that was great. Does anyone else have any questions as we wrap up today's session? Feel free to unmute or throw those into the chat. Doesn't look like it at the moment. Getting some great chats and good part 2 to the part 1 in the series. So thank you so much for putting this on again, and super helpful.
Yep, it was good. I enjoyed giving the talk. I'm sure there's many other random topics in Git that I could talk about. But if you have any questions, just feel free to message me.
Perfect. All right. Well, thank you so much, Ray, and everyone have a great rest of your day.
Thank you.